Right. So if we run this, we take a look, there's stats, herbs, oral string, and movie. Now, each one of these tuples has multiple items. You can create tuples that just have a single item. Like this, we could say something like scores equals, and we'll pick a number 89. But you have to, nevertheless, you have to include a comma to tell the compiler that you're creating a tuple and not just simply the element itself. So if I want a single item tuple, I have to do something like this. Um, if I, on the other hand, if I said, let's change the name, say score um, equal to 89, and I leave the comma out, then you just simply have an int value. You have it's immutable, but it's not a tuple anymore. It's just an integer value. Okay, so you got to include the comma. Um, so let's see, we still have herbs. Let's play around with this stuff a little bit. You access items in a tuple. You use the indexes within brackets just as you would do for the items in a list. However, since the tuple is immutable, you can only use the syntax to get items, not to set them. What does that mean? Well, again, here's herbs. Here's our herbs type. And if I want to access one individually, like the first one, lavender, I could just say I could index it, use its index, which is 0. Um, or you can start from the end, which again, I sometimes I have difficulty seeing the utility of doing this. Um, I'm not sure if you can do it in other programming languages. I know you can't do it in R, right? So this will walk it from the back, right? Oat straw is the very last one. Or if I say -2, we should get the one nettles. So counts forward from 0, counts backwards from -1. If I ask for something that's out of range, if I say herbs -7, we'll have a problem. And it will give you the class of error, index error, tuple index out of range, which is pretty easy to recognize. Or if I do something like this, so here's herbs again. If I try to change one of the elements, for example, like you can do uh, with lists, for example, if I say herbs, I want the second element of herbs to be equal to red clover as a string. It won't like that. And the reason is obvious. Tuple objects are immutable. So you can't assign a new value to one of the items in the tuple. Okay, so you can also, let's take a look at this. You can so-called, here, let's go to the slides. You can unpack what's known as unpacking the items in the tuple by using a multiple assignment statement. And so this one's pretty clear, and I don't have it on the slide. I could do it manually, I suppose, where we create this tuple called tuple values. And that worked. We can unpack it and use and do multiple assignment at the same time by doing something like this. Now A has the first value, B has the second value of the tuple, C has the third value, and so forth. Okay, here's a function that returns a tuple. Let's look at the slide and then actually this isn't quite complete. This isn't quite correct. You have to, within the function, you need to actually assign values to X, Y, and Z. Let's look at the script. This is on slide 56. Right, so here's the definition of the get location function. Within the function, it assigns values to X, Y, and Z, and then it returns all three of them. Note a couple of things here. One, as we mentioned before, with Python functions, you're not constrained to just simply returning a single thing, a single object. You can return lots of different objects. So it's pretty obvious what's going on here. Let's run it. So create this function, X, Y, and Z. And then if we say what's X, X is 1, what's Y. So again, we're unpacking the tuple, but with a function that does it. Okay, it's a simple example, but of course you could imagine how you can extend it. Okay, so that brings us through tuples. And again, notice really all Murex does there is identify some of the unique things you can do with a tuple. Now, you might wonder, well, why would I use a list versus a tuple? Well, in general, you would use a list because it is more flexible, because for precisely the reasons that you would not use a tuple, you can add things, insert things, delete things, and so forth. So you can, when you're processing data, you're usually in some sort of scenario where you have changing values for certain variables, and you want to use a data structure that can capture and reflect those changing values. Well, then why would you use a tuple at all? Well, I can't give you a specific example, but you could probably imagine instances. You could think of them as constants. You could think of a tuple. Tuple is a list of some variable values that you don't want to ever change. Okay. And again, you could probably think of some examples where that would be useful, where you're applying an unchanging value to different things, to different sets of data. Okay. So here's a program, the number cruncher program, which is the end of this section of tuples, and looks something like this. And if we run this, let's run it, and then we'll go back and take a look at the code. You notice there's two main parts of the output. One thing that says tuple data, and these are the values for the tuple, and the other one that is random data, and these are the values of the random data. And within each of these two parts of output, it computes the average, the median, the minimum, the max, and the number of dupes that are in it. Let's run it one more time. There's something wrong right here. Let's take a look at it one more time. Run it again. Oh, I see. This isn't the number of dupes. This is the value of the item. 10. Yeah, 10 repeats, right? So that was my confusion. You don't have 10 dupes. This item is a duplicate. And down here you see these two values, the two items that have the values of 16 and 28 repeat. There's 16 and there's 28. Okay, and that's really about the only clever thing that this program does. Let's take a look at how. And we can do this in the code, I guess. Okay, let's do it on the slide. Sometimes that's easier to comprehend. So this is the output. Notice the tuple data, I ran it twice. It's always going to turn out it's fixed. You have these fixed data elements, values of data elements. Random, of course, will change every time. Okay, so what's going on here? Well, we're importing the random module. The main guts of this program is in the crunch numbers function that displays those statistics on the second line for the tuple in the list. Average, median, min, max, and duplicate values, if any. Well, pretty transparent how it computes min, max. To compute dupes, it calls a different function altogether that's on the next slide. The average, again, is just simple arithmetic, the total divided by the number of items in it. About the only thing that requires any brain power to understand is the median value, this line here, and the median is the middlemost value in a set of numbers, I believe. So it calculates, what it does here is it's calculating the index for the median value by dividing the number of items by 2 and using the modulus, by truncating the result using the integer division operator with the two division signs. Okay, so it finds the index to get the median value, which is the value that half the values are below and half are above. Okay, so and then it prints out all this stuff. Get duplicates. So in order to identify the dupes, it calls this function over here, get duplicates, which sets up an empty list and then uses this for loop It loops through the numbers. It goes through the range of possible numbers is from 1 to 50. So it loops through this set of numbers from 0 to 50 to get the count for each number, and appends that number to the dupes list is the count if the count is greater or equal to 2. Okay, well, what does that mean? Well, it's going through every possible number, and you remember count is a method with lists that will return the frequency. Okay, so if a number only occurs one time as it goes through this loop, it will have a count of 1, and it's not a duplicate. But if the frequency of that particular value of the element is 2 or more, then it's appending that item, which is obviously a duplicate, to this dupes list. And so it loops through all of the possible numbers that could be there, and it figures out what's the frequency of them. And if the frequency is 2 or more, it sticks it in this, it inserts it, or appends it, I should say, to this dupes list, and then it returns dupes. Okay, so the tuple, we create both a tuple and a list. The tuple is always fixed. Okay, but the list consists of random numbers, 11 random numbers.